find the derivative of y equals tangent inverse of ln of x. All right, so we do see that inverse, right? So we were going to find the derivative of the tangent inverse function. Let's just write down what that formula is. Okay, so if y equals tangent inverse of u, and I'm putting u here because, well, this is not just x, right? It's an ln of x, so this is a composite function. Okay, so basically we need to use a chain rule on this guy, right? So we know that dy dx, okay, so the derivative of the tangent inverse function, or the arctangent function, is 1 over 1 plus u squared times du dx. Okay. In this case here, we see that u is equal to ln of x, right? So that's going to be essentially this u and, the derivative of u that we need to find here. Okay, let's go ahead and do this, right? dy dx is going to be, 1 over 1 plus u squared. But instead of putting u, what do we put? We put ln of x, right? That's the inner function here. So ln of x squared, okay, times the derivative of u, right? What is the derivative of ln of x? That one's pretty straightforward, I guess, right? The derivative of ln of x is just 1 over x. Okay? Now, we should combine this all into one fraction, so we get 1 over, and because it's a plus here, we got to distribute it, so x, or actually let's just put it in parentheses, right? X plus 1 plus ln of x squared, and that whole thing in parentheses here. Okay, now you cannot do anything with this guy, right? So ln of x squared, right, is not the same as ln of x squared, right? This is two different things. Here, this one, ln of x quantity squared, there's nothing we can do about that. This one, we can bring that 2 down to equal that, but once again, these are not the same. So we would just leave this as our final answer.